Hi, this video is for Statistics Chapter 2.2. We're going to look at three types of graph: histogram, frequency, polygon, and time series graph. In our course, I'm going to skip time series graph. If data are collected over time, we can graph it according to time. So we're going to skip over it. So we concentrate on graphing data by looking at its distribution. So what is histograms? Histogram is very similar to a dot plot where you show the distribution of data by stacking the data vertically, but you would use class instead of just one number. So histogram are used to show distribution of medium to large quantitative data, and data are summarized into frequency classes. So in dot plot, we would have numbers, right? 4, 5, 6, one number, 7, like that, and then you stack up the data. There's that many of them, right? But in a histogram, instead of these, you would have bars. If there are more data here, the bars will be higher. So basically, it is frequency in the vertical axis. And instead of one number, this would be a range. So maybe 10 to 20. And then there's another bar, 20 to 30, right? 30 to 40, 40 to 60, like that. So these are class range, just like a frequency table. So instead of one numbers, this would be 10 to 20. So we've got right 10 to 20, 20 to 30, like that. 30 to 40, 40 to 50, 50 to 60, right? So when we have the bigger graph, you see. So then you can see, oh, where's the most of the data is? Oh, the most of the data is here. And how do they spread out, right? So a histogram shows a lot of information about the distribution, particularly where are the data is. Is it symmetrical? Is it scale? Like that. So the bars are contiguous. So unlike a bar graph where we use to summarize categorical data, histograms will have frequency bars. We say they're frequency bars. So remember, these bars are not a data value. So in the y-axis, these are frequency. Just like it doesn't mean there's a data too. The data value itself is here. So the data values are here in a range. So contiguous bars, no space in between. Some graph actually put some space in between, but there should be none. You would not have a lot of bars. It typically should have about 5 to 15 bars or classes, and each bar represents one class of data. And you have lower limit, upper limit, just like when you build a frequency table. Histogram can show the distribution of the data, where the center is, how they spread out, but data cannot be recovered. Histogram can roughly talks about if there's outliers, and outliers are usually away from the rest of the data. So I'm going to do an example of a histogram that has outliers. You will see data are clustered around these, bars. So maybe I don't want to do that. There's not enough space. But then there is a data with frequency. So this is a frequency, right? The frequency is really low. This is 1 or 2. So just 1 or 2 away from the rest of the data. So this could be 4. This is 8, and this is 5, and this is the frequency. And then I have 1 to 5 to plus 4 plus 4 is 9, plus 4 is 13, plus 4 is 17, right? So 1 to 5 is this. From 1 to 5, there's 4 data. From 5 to 9, there's 8 data. So, and I think this is 4. So you can see that most of the data are clustered around here, but there is one that is 25 to 30 to 29, for example. So that would be there's an outlier. The outlier is in this range. Okay, there's a large gap. We call this the gap from the rest of the data. So typically, you see a histogram like that. You see, oh, there's an outliers. And you would look at the main data to see how the data are distributed. So first of all, let's look at an example of a histogram. So when you see bars that are contiguous with each other, And at the horizontal axis, they are not category names. They are not like colors or cities or names, but actually data values of ranges. Then you know it is a histogram. For example, this one had 180 to 200. So this means there's the data values are from 180 to 200, and that's two of them, right? Two means two of them. And 200 to 20, there is what? 10 of them. So there's 10 data from 200 to 20. So 10 is not the data value. 10 is the frequency. There is a lot of 200 to 20 around here. So that's how you interpret a histogram. It shows not the values of the data. There's no data value of 10. There's no data value of 9. But actually how data distribute. Most of the data is around I would say around the highest bar and this one, right? So it's around 200 to 240, right? So this is where the center is, and they distribute from 180 to what is it 300. So it shows how they varies. It also shows the shape. So it is obviously not symmetrical. It's skew, right? It's skew. And most of the data is in the low end, right? So this is where the peak is, and it's in the low end. So answer this question: how many players are on the team? So these are show distribution of weights. So these are weights data. How many players are on the team? So you will add all the frequencies. So let me write the frequency. So this frequency is 2. There's 10 data in this range. There is 9 data in this range. There's 220 to 240. And there's 7 data in the 240 to 260. There is 4 data from 260 to 280. And there's 2 data from 280 to 300. And the number of players would be 2 plus 10 plus 9 plus 7 plus 4 plus 2. I don't think I can do it in my head. So it would be 12 plus 9 plus 7 plus 6, 34. So total 34 data. They're all like 100, 200 something. How many players weighs between 240 pounds to less than 250? 240 to 250. So that would be this class, right? 240 to 250. How many players are there? There's 7. I will look at the frequency bar is 7. So there's 7 of them, but we don't know what data they are. We just know that it is within that range. How many players weigh from 220 pounds to less than 240? 220 pounds to less than 240. So that would be this class, right? So that's 9. How many players weigh less than 240? So all less than 240 is where? Is here, right? All these are less than 240, and we'll just look at the bars. So that would involve 2 plus 10 plus 9. All these weights data values are less than 240. And then there are 9 of them, 10 of them, and 2 of them. So you add them together is 12 plus 9 is 21. So you can see that a lot of players are on the low end. On be above 240 is very little. So you can see that it is skew. The data is a skew. What percentage? So instead of finding the number, so I should say 21 players. I should not say 21. It seems like they're very. What percentage? So players less than 200 pounds. Okay. How many less than 200 pounds? So 200 is in this range. Below 200 would be here. So only 2, right? Only 2. But I want to know the percentage, not the number. So 2 out of 21, because no, 2 out of 34. 34 is the total, right? Because we see the number of player here, total player is 34. So it should be 2 out of 34. I was looking at that one. 2 out of 34. So that would be 0.00588. So that would equal to 5.9%. Usually we round to 1 decimal move, right? So 5.9% of players are less than 200 pounds. Okay. Can we determine the exact number of players with weight exactly 245? 245 is in which range? It is in the range of 240 to 250, right? So there's 7 of them. But do we know what the 7 numbers are? We actually don't know. No. There are 7. The frequency is 7 between 240 to 245, but we don't know how many exactly 245. So that's how we use the histogram to understand the data. Although we don't see the data, we can tell how many are greater than how many data are greater than a number, how many greater than less than a number. So that's very useful. So the next thing is how to graph this histogram. So I'm going to do it in another video. I do not need you to know how to graph it in the test. I'm not going to test you because you will do this when you're doing a project. So you can learn it slowly. In the class worksheet, I have one question that asks you to do it. So maybe we'll do it in class. But you don't worry. You don't need to worry that there's a lot of like details on how to graph things. I don't remember. The most important thing is to understand if you have a histogram, how to interpret it. Um, Using the histogram to understand the data.